looking at multiplying and factoring. So first of all, factors are numbers or variables that you can multiply together to get a product. Okay, so it's important to realize that you can factor both numbers and variables. Commonly, people do forget that you can factor out variables as well. So let's go here. Let's name the factors of 32 and 90. Okay, so when you're thinking about factors, start with the easy one. A number times 1 is itself. So for 32 here, we can start by listing the factors 1 and 32. Then we can work our way down the list. Is 2 a factor? 2 times what gives us 32? Well, we've got 16. 3, well, 3 does not divide out of 32. But then we've got 4 times 8 gives us 32. And keep working your way down the list. How about 5, 6, 7? Nope, 32 is not a factor of, well, those are not factors of 32. We've worked our way back to 8, so we've completed the entire cycle here. Okay, we can do the same with 60. So for 60, let's start with the obvious one, 1 and 60, and work our way through the list. So we got 1 and 60. 2 times 30 gives us 60. 3 times 20 gives us 60. 4 times 15 gives us 60. 5 times 12 gives us 60. 6 times 10 gives us 60. And we've made it quite a ways here. 7 times, nope, 7 does not divide out of 60. 8 times, no. 9, no. And we made it back to 10. So when you're finding your factors, I will give you guys a factor chart to use during class, but if you need to find the factors yourself, you may want to use a calculator and, just create one of these tables. So another key aspect of factoring is to realize how components can be rewritten. So first of all, let's rewrite this little monomial here. So 2 doesn't have any factors, but 2 times 1. So I guess if we wanted to rewrite 2, we can rewrite it as 2 times 1. X squared is the same as saying x times x, and then we just have a y on the end. So as you can see, although we had a monomial that was all pushed together being multiplied, you could expand it if you wanted to. So multiplying monomials and polynomials. So commonly when we're multiplying monomials and polynomials, we have to use the distribution property. But I'll get into that once we get to those examples. So remember, the rule for multiplying with exponents. So when you're multiplying terms with exponents, the coefficients just multiply together, but the exponents will add. Okay, this is just going back to last chapter here. Okay, so let's go through our first example. So our first example is the distribution property. So you'll multiply 5n to all 3 of these terms. So remember, multiply your coefficients. So 5 times 3 gives me 15. N times n cubed. Remember, this n does have an imaginary 1 there. So n to the first times n to the third. Add those together, gives us n to the fourth. Minus n squared. So 5 times -1 gives us -5. N to the first times n to the second is going to give us n to the third power. Then finally, times 8. 5 times 8 gives me 40. N to the first times, I guess, 1 is just going to give us n to the first. So that's our final answer there. Okay, so that's how you multiply monomials. So let's take a look at the greatest common factor here. So plenty of times we're going to be given a polynomial and we'll have to find the greatest common factor. So for greatest common factors, there's kind of two components. There's your coefficients and then there's your variables. So the greatest common factor of 3, 9, and 1. So how we figure out the greatest common factors is you have to look at the factors of all three of these separately. So let's make a little factor tree. So a factor tree for 3, I have 1 times 3, 2, no, that's it. For 9, you would have 1 times 9, 2, no, 3 times 3. Well, we've obviously completed the cycle. And then for 12, you would have 1 times 12, 2 times 6, 3 times 4, and once again, we've completed the cycle. So if you look at all three of these, each of them has a factor of 3, and each of them has a factor of 1. But that's it. And obviously, we're looking for greatest common factor, so we're looking up for the larger of the factors, which in this case would be 3. So the greatest common factor would be 3. Now look at your variables. We have x to the 4th, which is just x times x times x. I'll write this out. X to the 2nd, which is just x times x. And then we have x, which is just itself. So when you're working with variables, you're seeing what's the maximum amount of variables that they each have in common. Well, in this case, they each have one x in common, but then x runs out of x's. So the greatest common factor for x to the 4th, x squared, and x is just going to be x. So put those two together, the greatest common factor for this polynomial would just be 3x. Okay, so that's our process of deciding the greatest common factor when working with polynomials. Okay, so now we're going to take that greatest common factor, which was 3x, and we're going to divide it out of our polynomial. So how you do that is you start by writing your greatest common factor, and then you divide that out of each terms. So first one's here, or wait, we'll do it individually up here. Divide all terms by 3x. So if I have 3x to the 4th divided by 3x, okay, I'd have 3 divided by 3, which is just 1. X to the 4th divided by x. Remember, when you're dividing, you are essentially subtracting. So x to the 4th minus x to the 1st, 4 minus 1, it's going to give us x to the 3rd power. And actually, I'm going to write this as a fraction for the next one. So negative 9 x to the 2nd divided by 3x. I have negative 9 divided by 3, which is just negative 3. X to the 2nd divided by x, which would just be x. And then I have negative 12x divided by 3x. Negative 12 divided by 3 gives me 4. X divided by x, they just cancel each other out, which just gives me 1. So now, how you're going to write this is you'll write your greatest common factor out in front, which is 3x, and then you'll write all your divided terms. So I've got x cubed minus 3x plus 4. And that's my factored form for that polynomial. Okay, we can do this other example together in class, but let's keep moving. So for all of these examples, we're looking to factor them. So you have to look at each term and find the greatest common factors. So for both of these, remember you look at coefficients and variables. So let's look at both my 3 and my 12. So the factors for 3 is just 1 and 3. My factors for 12 would be 1 and 12. We've already done this. 2 and 6, 3 and 4. So my greatest common factor is just going to be 3. So once again, we'll write our greatest common factor out in front, and we'll divide all of the terms by 3. Because in this case, 12 doesn't have any x values, so we can't factor out any x values. So 3x divided by 3 is just going to give me x. 12 divided by 3 is just going to give me 4. Okay, we can do the same with this next one. Let's start by looking at our coefficients. So I've got 15, and I've got 30. So I would have 1 and 15. For 15, I would also have 3 and 5. And that would be about it. For 30, I'd have 1 and 30. 2 and 15. 3 and 10. 5 and 6. So let's go ahead and highlight all of our common factors. So they both have a common factor of 1, common factor of 3, and a common factor of 15. So obviously, 15 is going to be our greatest common factor. So I also now want to look at my variables. If I've got a squared, which is a times a, and I've just got a, which is a, they both have one a in common. So that can be a factor as well. And now looking at b, I've just got b and b, which they both have a b, so I might as well factor that out. So in this case, I'm looking to factor out 15a times b. So now we have to look at what would be left if I factor those out. So let's divide them one at a time. 15 divided by 15 is 1. A squared divided by a is just a. And b divided by b is just 1. So I would just have a left in my first term. But then in my second term, negative 30 divided by 15 gives me negative 2. A divided by a is 1. B divided by b is 1. So that is what I am left with. Okay, let's take a quick look at the next page here. And I actually think that is it for this lesson. Okay, so factoring is going to be a very long process. Okay, we will work on this for a very long time. So if you aren't totally understanding it as of now, be patient. It takes lots of time to learn. All right, please try the other factoring examples on your own. Come to class with as many questions as you have, and we'll make sure to go over all of the examples. All right, thanks for watching.